we mean by that is communal, but this is why we need to get different perspectives. All right, Sonesh.
Thanks, Eric. Good morning, everyone. I don't know if the mic is working. Can everyone hear me in the back? All right, excellent. Thank you. So I'm really thrilled regarding the registration for this conference, given that kind of event it is. I'm also really excited to be able to present and I'm graduating this year, and I can say hands down it's been the best years of my life. It's been great for some of the results that we've been able to achieve, but it's also been great for me personally because of the people I've had a chance to work with. This in particular is joint work with Rabin, Serju, Lakshmi, who's now a professor at NYU, and Eric. So to start off, enabling sustainable rural wireless telemedicine at Arvind Eye Hospitals. So I want to sort of first just take a quick peek into framing this. Since the end of World War II, there have been many mechanisms for multilateral aid for developing countries that have emerged. These include World Bank, UNDP, and of primary concern to projects under such aid is the idea of sustainability. Can pilots, initially supported by such aid, move beyond that stage and scale and be sustainable? Now, while there's a general consensus that ICT can impact development positively, it's been hard in practice to be able to create truly sustainable projects. And part of the reason for that is some of the implementers and researchers, us included, tend to underappreciate some of the challenges that lie in scaling. And these can include financial constraints. For example, the system may be too expensive, and the low paying power of the community that it is serving. And implementers are not going to be with this project forever. So at the point when we leave, what stage is it in for people, the community, to take over and use the technology and to cope with issues such as power, hardware, or software errors in our absence. So with this project at TIER, if sustainability is the goal, we have taken one view, and we have found it helpful to use or refer to some of these three principles that we didn't really know beforehand, but sort of evolved as the project progressed. So for almost generally for almost any task in a community, there is an existing approach. It may not be a good one, but it is an existing approach, and we found it helpful to view our project as optimizing or enhancing that existing approach. Partly because it's easier to get community buy-in, and motivation is easier, which is fundamental to sustainability. The other thing we want to look for is financial self-sufficiency, and over here in particular, I mean positive cash flow. Ideally, we'd like to be profitable, but positive cash flow is a hard enough goal as it is. And if we can recover our operating costs, then even under this view, we can use initial aid just to start up, and then beyond the pilot, we can cover our own operating costs, which is a pretty good model for now. And then we also look for operational self-sufficiency, which is essentially, can local staff handle the deployment or the technology after we leave? What do we do? Design robust components, maybe providing some easy management tools. So for this project, I'm going to try and look at it through this broad lens of these three principles. And I'll revisit them briefly at the end. So, telemedicine at Arvind. Let's start with some background. 45 million people are blind globally. 15 million of those people are in India. India shares the largest burden of global blindness. There's a saying in India that a blind person is basically just a mouth with no hands, implying the economic burden that blindness presents. Now, However, 70% of this blindness is actually treatable. It's either due to cataract, which can be fixed by a simple cataract surgery, or is due to refractive errors, which can be fixed by the right powered spectacles. Now, generally, if you can fix it, it should be fixed, and this is why this kind of blindness is called needless blindness, which is what Arvind refers it as. So, here you can see basically cataract and their refractive error, which are easily fixable. Okay. Now, what about the eye doctors in India? So, there are about 10,000 ophthalmologists for 1 billion people. Contrast that with the UK, where you have 10,000 ophthalmologists for about 60 million people. On top of that, in India, 700 million people live in rural areas, and only 1,000 of those 10,000 ophthalmologists live or practice in rural areas. So what that means is, in rural areas, you basically have one eye doctor for 700,000 people. So there's not going to be one near you. You're going to have to travel a bit. So what about the patients? So you have patients who are crippled with some eye problem and are not able to travel by themselves. They have to pull someone to go with them. And if they're daily wage laborers, not only do they lose their daily wage, they have to spend extra to travel this distance. And on top of that, when they reach the hospital, there's no guarantee that they're actually going to get the time for a doctor. There could be a lot of people waiting there already, or the doctor could be unavailable. Even things like 20 to 30 rupees that they have to pay for food expenses along the way, or a 60 to 80 rupee bus ticket can deter them from going. And what happens is that most patients often choose not to go until it's very late. And at that point, it actually becomes even more expensive to treat their condition because it has worsened in the meantime. All things that can be prevented. So our immediate need is really to increase the utilization of doctors. Of course, the long-term agenda is to increase the total number of doctors, to increase the total number of support staff, optometrists, paramedics, that can help in a lot of these eye care situations. But that is a very long-term goal. It's not going to happen overnight. In the immediate term, we want to be able to increase the utilization of doctors, which means how can a doctor see more patients than they normally do, and how can technology aid in that? So our partner in this project is the Arvind Eye Care System. They're a group of hospitals in South India, in the state of Tamil Nadu, in the places Madurai, Theni, Tirunelveli, Coimbatore, and Pondicherry. And they've been relentlessly working towards eradicating needless blindness in rural India. Now, they have been a fantastic innovator in this space. What they've done first is to really bring down the cost of eye care. They manufacture everything that is needed for cataract surgery, the lens, the sutures, the needles, the post-operative medicines, and can really bring down the cost. And so the cost of cataract surgery over there is $75 compared to, say, approximately $2,500 in the US. However, that there still is a shortage of doctors, and the doctors need to access patients. It's not just an issue of cost, but it's also an issue of access. So what did Arvind do the first time? Their first approach was rural eye. They would take a team of doctors from the main base hospital and ship them out for a day or two to a remote area. And there they would set up a tent, get maybe 500 people to come and do comprehensive eye exams. And this was a great start. For example, in the year 2006, they did about 1,500 eye camps, and they had about 600 people on average per eye camp. Of course, in your village or nearby your village, an eye camp might come maybe once a year or twice a year, max. And an Arvind study found that these kinds of eye camps, while they were a significant improvement they only reach 7% of the targeted population in that area, where the targeted population basically means those in need of eye care, mostly through because of cataracts or refractive errors. So it was doing the job, but not quite. Approach 2. I said, well, let's try telemedicine from rural vision centers. So what is a vision center? Basically, they rented a room in someone's house in a village for $50 a month. They would staff it with 2 women, 10th or 12th grade educated women, and they would specifically train them for another 12 to 18 months on some basic eye care procedures, and their combined salary was about $100 per month. They would set that room up, as you can see over there, with some very basic equipment, slit lamp camera, vision drum, some refractive testing equipment, maybe some blood pressure devices, glucose monitoring devices, a PC, and a webcam for video-based telemedicine. The entire cost to set this thing up is about $11,000. What was the advantage of having a vision center located permanently? Well, the first thing is that it extended the reach, it had the promise of increasing the utilization of eye doctors. It would save time and money for patients. And also, the permanent presence is actually key to sustainability. Well, one, the eye camps are not as effective because it didn't actually encourage care-seeking behavior. If I know a camp is going to come to me in 3 months, I'm going to wait for 3 months, and my condition is going to worsen by then. And if I do go to an eye camp, what are my opportunities or chances to follow up? It's going to come back maybe 6 months from now. There was no sustained awareness. With a permanent center, you can promote and encourage care-seeking behavior. You can also build capacity of the local staff at the center, because now, on a weekly basis, they can see about 100 cases that actually builds their own capabilities, which is a big win in taking the load off the doctors as they get more and more expertise. So here is typically what they envisioned happening at a vision center. Patient would enter, they would get examined by the paramedical staff, which would be basically a basic blood test, a glucose test, a height check, weight check, refraction test, maybe a quick look through a slit lamp to see any obvious cataract, and then they'd get put on a teleconsultation with the doctor. If the doctor suggested something, then the medicine or any minor procedure would be prescribed right away and conducted at the vision center. If a referral was needed, then an appointment would be given, such that when the patient actually went to the base hospital for any complicated procedure like a cataract surgery, it would be guaranteed to see a doctor at that time or thereabouts. So it was worthwhile for them to undertake that journey to the hospital. So all this talk of telemedicine was great, but the question was, what networking technology should we use for telemedicine? In general, the answer has always been sort of, whatever is available, of my options, I'm just going to use the cheapest available. And so Arvind initially chose Cordet, wireless local loop, and I'll talk about it a little bit. In general, it has been a good technology, but it's sort of outdated for the kinds of uses that Arvind would like to put it to. Our solution was using Wi-Fi, modifying it for long distance, and we call this Wi-Fi for long distance, or WILD, and you'll be hearing a little bit more about this in a future talk in this workshop. So, what were some of the disadvantages of Cordet? So first of all, it required a base station that was complicated to maintain and required a carrier grade or carrier grade trained employee to maintain that base station. The next thing was it required license frequency, which means that even if you did not have internet, you would still have to pay subscription fees on a monthly basis to use that frequency. The other thing was that it was operated by a private carrier. Now, that really restricts your operational freedom, because carriers are only going to go into those places where they see they can make a profit. So in many cases, Arvind was all ready to set up a vision center at some place where they knew there was high demand for eye care services, but could not go there because the carrier would refuse to set up a base station there to provide coverage. So what do we do now? I also had some limits to coverage, and in terms of bandwidth performance, it was kind of like dial-up speeds. So the audio was good, but it did poor video and was not likely to be able to send real-time high resolution images of the retina, which were taken at the vision center. So here's a typical setup at one of our vision centers with Wi-Fi. And just to quickly go over it, I mean, unlicensed frequency, so you don't really have to pay anything. We don't use internet. It's all a private network, so it allows for grassroots style deployment. You can, once you decide that there's demand over here, you can go set up your own link. The equipment is low cost and can easily be installed and maintained with some amount of training. The disadvantage is that Wi-Fi is basically a hotspot technology, so it hasn't been designed for long range. Has typically a radius of coverage of around maybe 1,000, 2,000 feet, and maybe a kilometer if you use high power radios and better antennas. And so it doesn't really match the kind of deployment we would like to do, where our vision centers are far away from the hospital, and trying to create overlapping hotspot zones such that you get coverage all the way through is extremely expensive and complicated to maintain. So using Wild, here's an example of the network we developed at the Arvind Thaini Eye Hospital. So in the center you see the eye hospital, and all around you basically see those red pluses are the vision centers, and the white dots in between are relay points that we had to use because we didn't have line of sight directly from the hospital to the vision center. And these pictures kind of give you an idea of sort of how grassroots style or bottom up the deployment was. I mean, we would put antennas on people's houses, sometimes on the roofs of the vision center itself, or sometimes we'd find a chimney from a factory nearby, and we'd negotiate with them to see if we can put an antenna up on that chimney. And on the other side, you can see some of the vision centers, the hospital, and an actual picture of a video conferencing session. Now this is a set of 5 vision centers. Today we have 12. I'm not showing all of them in this picture. There are other hospitals that also have sets of vision centers around them. Madurai has 3 and Tirunelveli has 2 at the moment. So let's talk a little bit about the financial self-sufficiency. So the 5 vision centers that I presented on the previous slide, here are their 2007 financials. All values are in US dollars. Income includes fees from patients for consultation, medicine, spectacles, and other minor procedures, and also referrals from the hospital for any patient that is referred from the vision center to the hospital. Expenses include basically salaries, the rents, any operating costs in terms of refills for the equipment, electricity, phone, and all of that. And you can see that just purely in terms of operating cost, 4 out of 5 are cash flow positive. It's not much. For example, if you look at the last one, Periaculum, it makes $180 a year, which is about $15 a month. But the key point there is that it's not losing any operating money. Let's take a look at Bodhi in a little bit more detail. So Bodhi was cash flow positive for 2007. Okay, so it made $1,150. This excludes. We talked about income and expenses. This actually excludes the cost of running the network. So let's look at the network costs a little bit. So it costs about $18 per link per year for maintenance. And we do this by actually using a local vendor that we set up a partnership with to take care of these links. So since it's a 2-hop link, it costs about $37. Let's look at the total capex, which includes all the equipment and part of the shared tower and the relay. That's about $1,800. Now, if you view this as spreading the cost of this throughout the lifetime of this equipment, assuming a 5-year lifetime and 8% interest, it comes out to be about $385 a year. So add that up with the $37, it comes to about $410, $15, something like that. So given an operating cost or a cash flow of $1,150, you're still subtract 400 odd from it, and you still have 700, and you're still cash flow positive when you think about the network operating and capital expenditure. What about setting up the VC? So now you have $728. The capital expenditure is actually $11,000. So if you assume optimistically that we have a 50% salvage value after 10 years, this actually translates to $1,200 a year. So we're still losing money. We're losing $500 a year. We're not profitable, but we're close. And obviously increasing the number of patients will help us. But the key point over here is that once created, the centers can be sustainable. So you do need some initial aid outlay, which is on the order of maybe $11,000 or $15,000, whatever it takes to set it up. But after that, you can be on your own, which is a big win. And prior approaches could not do this. Let's take a brief look at operational self-sufficiency, which actually is kind of its own talk by itself. But the first thing we did was extensive training. Obviously, once you train them, they get better and they leave, which is actually a good thing. What that means for us is that in terms of the tools we provide, we want to now reduce the need for trained staff. So we want to push a lot of the support for automated diagnosis and recovery and robustness to power in the tools that we provide them, rather than requiring like expertise from them in the very basic cases at least. The other thing that we did was we set up a 3-tiered support system, which means that after having trained the Arvind guys, they would be the first tier of support. If they couldn't fix something, we found a local vendor, Tulip, which helped us with the installation and the maintenance of the links. And only if they couldn't do things, they would come to us. And this actually was a big help in allowing us to hand off the system to Arvind. So let's look a little bit at migration of responsibility. So initially, we were involved with everything: equipment supply, installation, management, and maintenance of the whole network. That's us. As time went on, as we did our training, we basically got Arvind to do a lot of the maintenance, and then we got Tulip to do a lot of the installation, management, and maintenance as well. And right now, I'm happy to say that we actually don't do anything at all, and in that time, they've set up 5 clinics. And actually one was set up 2 weeks ago, and one will be set up 1 week from now. And the best part is I'm actually here talking to you about it, not there doing it myself, which is great. So very briefly, some patient throughput results. So the blue color represents, each color represents a hospital. Shades within the color represent different vision centers. As you can see, as we added vision centers, the patients jumped up. We've done 90,000 patients. Vision has been restored for about 16,000 people. All the patients that you see in the box are basically vision centers that we enabled where there was no other network coverage and there was no other eye doctor available there. So 90,000 patients screened, 17,000 were diagnosed with vision problems, about 16,000 had their vision restored, and really every month 30% of the patients are follow-up, which means that the quality of care is now much higher than in the ICAM case. And basically an Arvind study revealed that 96% of the people who get cataract just lose their jobs, but those who get surgery, 85% of men and 58% of women get their job back within a week. So to quickly wrap up, we just want to visit the 3 principles again. So optimization of the system. How do we optimize? We improve access to existing doctors, that they were already doing this, increase their utilization, and has been better than prior approaches. Financial self-sufficiency. We choose technology such that its deployment costs would be reduced, and we got operational freedom that allow us to get access to more paying patients. Okay? And operational sufficiency. So essentially training of staff, IT management tools, a 3-tiered support system, which allowed us to completely hand off the system to Arvind. And this concludes my talk, and I'm happy to take questions. Sure. Thank you.
What's the cost difference between Vision Camp and the remote centers, and are Vision Camps still being used?
Vision camps are still being used partly because they don't have vision centers everywhere. The goal is to replace the vision camps with vision centers. So they have probably vision camps at about 50 different locations, and the goal for Arvind, and they're doing this on their own, is to be able to have 50 vision centers in those places.
So is there a cost difference?
So it's hard to actually talk about the cost difference because there are certain benefits that you don't get from an ICAM, which is because of the increased presence of the vision center. So in the long term, and an analysis of this hasn't been done, but it's anticipated that in the long term, in the 1 to 2 years, the cost difference would favor a vision center.
There's a wireless mic for questions, so if anybody has any questions, just raise your hand and I'll bring it over.
Thank you. One thing, you might have said this, but I might have missed it. I understand the argument for going to the vision centers, but why was the Wi-Fi where you chose to focus the work? Was that in some way the highest ongoing expense, or was it the low-hanging fruit, or what drove you there?
So the question was, the success of the vision centers really depended on good quality telemedicine. And the question was what network connectivity options we had on the table to be able to do those. And what we had at that time, we had pretty much no options besides Cordet WLL. And in that, if you do a comparison in terms of the operating cost, it was higher, Plus, it did not give you the operational freedom to just set up a network anywhere for you to be able to increase the number of paying patients you had. And so we looked at Wi-Fi, and the research problem there was, how do you make Wi-Fi work at these long distances? Because it's not designed to be. Yeah.
Sonesh, Jeff from Infinia.
Hey.
Hi, I'm interested in understanding a little more about how you got the $18 per link annual maintenance cost. I ask this because in some of our networks, a good single lightning strike will take a couple $100 out of equipment out of a link, and so we usually come up with a little more cost than that.
Yeah.
So is it from maintenance contracts, equipment replacement? Just a little more detail.
It's actually how to say this, a toughly negotiated maintenance contract with the local provider. And also there are certain things that work in our favor. If you notice in this particular graph of the network, the links are not that far apart. They're maybe maximum 30 kilometers apart. And so the travel costs are not that huge. And what our equipment or maintenance person does is basically have an engineer just stay where the link is in that area, because there are other links to take care of. And so the cost is shared that way.
Hi, I'm wondering about the subunit, sort of the business units within the Vision Center and how that affects the economics of the operation. So a certain amount is referrals to get cataract surgery somewhere else, but a lot of, presumably the cash flow is from medicines for things like the diabetes and selling eyeglasses. Mm-hmm. I'm wondering especially about the eyeglasses because...
Yeah, that's a very good question. So the way cataract surgeries work is that the model that Arvind has developed is that 2/3 of the patients actually pay at a subsidized rate for cataract surgery, and is subsidized by 1/3 of the richer patients that actually pay more for better post-operative care, even though the surgeries or the medical care for both classes are the same. And so what's happening at the Vision Center is that you'll see that the incidence of spectacles is higher than cataract surgeries, and it costs about $10 or so to get spectacles. And so a lot of the revenue comes from spectacles.
What's the markup on the glasses?
I don't know. It's $10, so I wouldn't know what the markup is actually. Yeah.
I have a question about the optometrists involved in the project and the workload that they're under and how that's changed before and after, and if they have any sort of comments on that change.
Sure. So the people who are at the Vision Center are not technically optometrists. There's a specific program that Arvind has created that is not accredited, but they train them to do some basic things. And those basic things include just blood tests and glucose tests and simple checks through the slit lamp camera. Over time, certain Vision Centers, we've noticed that the staff actually starts doing procedures that are not recommended because they're not accredited, but they're actually very good at it, such as surgically taking out thorns from people's eyes. They can do that. There have been instances where, an incoming doctor who's a new resident, the first thing he does or she does when, they have a problem is go talk to the staff at the Vision Center, because they've seen 3,000 cases by the time they have their first day over there. And so they actually get a lot of their practical advice from the Vision Center staff. But it's mixed. It depends on, I would say, a big factor is personality. Some people like to take risks, or some people just like to do what they're told. So it varies. Yeah.
I'm interested in what it would take to take this to scale. So you said there's 15 million people that need it. So let's say you want to reach 1/3, 5 million people. Are you missing another piece of technology, or are you missing a business model, or are you missing finance, or what's the missing piece to sort of go to scale?
So at the moment, we're covering about 800,000 people with 12 clinics. What Arvind's plan is to actually take this to 50 centers, covering close to the number you said, about 3 to 5 million people in terms of pure coverage. At the moment, given the spread of the hospitals, if you have even 10 Vision Centers per hospital, it is possible. So there's nothing really stopping that. What does help taking it to scale is a really good choice for the location of the Vision Center. They tend to locate it in places where they know that it has a high incidence or high estimated incidence of vision problems. and it is in a relatively easily accessible area with a high density of population. So if you look at some of these vision centers, so the rule of thumb is to be able to set one up where you have in about 5 kilometers about 50,000 people, and if you do the math, it comes out to be about 600 people per square kilometers, which is about twice the national population density of India. And so that helps with the business model.
Sonesh, my question is whether those areas where you have the vision centers have other form of communications like mobile phone coverage, community or FM radios, things like that. Do they already have that, or
they do have radio, they do have mobile phones. Some of the primary applications that they use are video-based telemedicine and transmission of high-resolution retinal images. They don't tend to use those. Of late, we've seen a proliferation of DSL into some of these places. So their strategy going forward, as I had mentioned, for the 50 vision centers is to take a mix of DSL where available if it's cheap compared to the Wi-Fi solution. And that's how they're going to move forward.
So we're going to convene now for about a 15-minute break. Come back at 10:55 for the next session. Promptly, we're just going to start the next talk with Matt Cam. So we'll see you. Have some coffee, and we'll continue with our talks.